All right, welcome to 4.4, proving triangles are congruent using the angle side angle and angle side postulate and theorem. So first off, we're going to go through what this postulate and theorem say. Similar to yesterday, now this time this represents angle side angle. So ASA for short, and just like side angle side, that there's an included two angles, and the included side need to be congruent. So for example, if I have this angle and this angle, the included side is going to be between the two angles. Between angles. Okay, so in this example, if I have these two angles, I need this side and the corresponding angles and corresponding side here. Those are all congruent, and the triangles are congruent. And the last one is the angle side theorem. Oh, let's try that again. The angle side. So here, the non-included side. So if I have this angle and this angle, the non-included side, I'd have two choices, right? Here's the included side. These two are non-included. It's not directly between them. All right, so we'll be using these to show triangles are congruent. So remember from last section, we can also use side angle side congruence postulate and side congruence postulate. So now we have 4 shortcuts for proving triangles are congruent. We'll get one more before the chapter's over. Important things to remember, we already kind of used, vertical angle theorem is very helpful, showing angles are congruent, alternate interior angles and corresponding angles, and all those theorems from chapter 3. Definition of an angle bisector. Remember, a bisector divides a segment into two congruent parts. Segment, or in this case, divides an angle into two congruent parts. And other theorems, if two lines are perpendicular, then they form 4 right angles. That was like theorem 3.3, but it's hard to remember the theorem number, but it's easier just to remember what it says, and it's probably more important anyways. But we'll use this to get right angles. And with this theorem, these two kind of go together. If you have the right angle congruence theorem says all right angles are congruent. So you can use this one to get right angles, and then this one to show that they're all congruent. Make sure you know the definition of midpoint. That divides a segment into two congruent parts. And make sure you know the reflexive property, that it's congruent to itself. Definition of triangle congruence. Remember that required 6 parts, congruent to 6 parts, corresponding parts. And these ones were a shortcut. We only needed to show 3 parts. Now, remember, angle, side, angle. The side has to be between the two angles. Angle, side. The side is not between them. All 3 sides, or side, the angle between the 2 sides. And don't forget about these ones, segment addition property, that you can add segments up to get the total. You can still do substitutions and definition congruence and transitive property. Those will still be important. So just like last time, we can look at these and say, are any of these triangles congruent? We look at the first one, we know all the angles are congruent, but we don't know anything about the sides, right? We don't know any sides are congruent to any side, so really you have to imagine that these things are not drawn to scale. So imagine that this angle, this angle, this angle, and this angle, are congruent. Are these triangles congruent? Heck no, they're not the same size, right? So once again, I'm going to say no, there's not enough information to show that. But a simple no in the homework will do. Okay, we need a side. We need at least one side. Now the next one, once again, we're only given things about an angles, right? So is that not enough information? Well, we can show that this side is congruent to itself, right? By the reflexive property. So that side is congruent to itself. So the answer here is yes by, notice the side is between the two angles, right? So this is an angle side, but since the side is between the two angles, it's side angle side. The third one, I look at this, and once again, what do I know? I know that I can use the vertical angles theorem to show that this angle is congruent to that angle. Add another. So now I have angle side angle again. And a third one, or fourth one, excuse me, I have an angle side side. And this is what I call the donkey postulate. Okay, donkey postulate does not work. Okay, it does not work, meaning that if you look at this, the angle is not included between the two sides, right? If it was between the two sides, you'd have side angle side, but the donkey postulate, angle side side, or side side angle, if you spell it the other way, would spell a bad word, and that's why we call it a donkey. Does not work, meaning we cannot use it to prove the triangles are congruent. So once again, we don't have enough information. Okay. A couple more quick proofs. Whenever I see parallel lines, I immediately think alternate interior angles and the corresponding angles. So we have some parallel lines like AD parallel to BC. Okay, the double arrows meaning those ones are parallel, and AB parallel to BC. Given. And now I'm trying to show ABC. This triangle is congruent to that one. So with these parallel lines, if I'm looking at these ones, here's my transversal. So this angle is congruent to that one because of the green lines. And if I switch colors here, these lines being parallel make this my transversal, which means this angle is congruent to that angle. So we can say those angles are congruent. Angle BAC congruent to angle DCA, as well as angle DAC congruent to angle AC and ACB. And that's the alternate interior angles theorem. Remember, the theorem shows angles congruence. The converse would show the lines are parallel. So now I have two sides, or two angles. I either need one more side, angle, angle, side, or angle, side, angle, depending on which one we get. And I know this segment is congruent to itself. AC is congruent to itself, and that's used in both triangles. So that's helpful, reflexive property. And therefore triangle A, well, I'm actually going to write it the same way. Yep, triangle ABC is congruent to, now let's just double check, A in this triangle, excuse me, corresponded with C, and B in this triangle corresponded with B, and A. Is that what we're trying to prove? ABC. And I think I might have that wrong up there then. Let me, A, B, C. A corresponded with C. So, yep, this should be flip-flopped up here to make this proof work. So, always good to double check that. If this, I made the question so I can say it was wrong and it should be flip-flopped, but sometimes you can't prove everything. And this would be angle, side, angle. The side is between them. Angle, side, angle, congruence postulate. There's your homework. See you in class.